Hello, college algebra. You guys are doing a great job getting your stuff in, most of you. Shout out to you guys that are on task. I'm going to go ahead and lecture on 7.4 next week, spring break. So this lesson, 7.4, is not due until the Sunday we come back from spring break. So that will be April 19th. Okay, so I'm going to go ahead and lecture. That way you can work on this lesson as you can. And then when we do come back from spring break, we have Monday, Tuesday to work on this, and then of course Wednesday. But then Wednesday, as usual, I'm going to go ahead and lecture on 7.5. So when we get back from spring break, there's 3 more lessons. We are this close. So do not gas out on me. Don't gas out, please. So hang in there. Topic for today called Properties and Applications of Logarithms. And it's really pretty quick. So just watch me, some suggestions. I know if you do have a printer, to print out this blank handout that I'm going to upload for you, and then take notes while you watch the video. Now, if you don't have a printer, just watch the video and copy the question down. That way you can see what one you're going to kind of use as an example. And hopefully that'll get you through your lesson without too much trouble. And again, guys, ask me questions. Take a picture, send it to me through Remind, and I will help you. That is what I do. All right? So please take advantage of that. And so first thing I want to talk about is properties of logs. Well, before I even begin, I always want to make you connect the logarithm to the exponent. Remember, the logarithm is the inverse of the exponent. So that's what you did in the last lesson and the lesson before that. So I'm just going to review some properties of exponents. And these are the easy ones. So here we go. I know that if I have x to the, say, 7th times x to the 3rd, I know you know what you need to do with those exponents. We add. All right. Well, if I have x to the 5th divided by x to the 2nd, I know you know that we subtract. Okay? So with those two properties in mind, that helps us explain the product property and then the quotient property. All right, so this product property, this first one, says if we have a log of any base and we have a product, so notice how x and y are being multiplied. Well, we expand. In other words, we write this logarithm as an expansion. So that's really saying the log of whatever the base was of x plus the log of y. So connect it back to the exponent problem, the exponent question. What did we do when we multiplied bases, same base? We added the exponents. Well, I do the opposite with a logarithm. When I have multiplication of a logarithm, then I'm going to end up adding those, and vice versa. When I see an addition, that means I've actually multiplied those two together. Okay? Now, it works for the same thing with a natural log. So in natural log of xy, x times y is a natural log of x plus natural log of y. Second property is quotient property. So log of any base, and I have x divided by y, means log of whatever the base was of x minus the log of y. So you're subtracting. So same thing with natural log. Natural log of x minus natural log of y would be this expanded. And then the last property we need to kind of remember or know is really, I call it the down and front rule. We cannot have an exponent here within a log. So that R that I just circled really goes down in front. He's in the way, so you just move him down in front. All right, so here you are at a ball game. You're trying to watch the game. Somebody's standing up in front of you. People are going to yell down in front. Get out of the way. So that's what we need to do. Get that exponent out of the way. So it becomes down in front. So notice how it says R times log of whatever it is times log of whatever the base is of X. Same thing with the natural log. Okay, down in front. So that's the way I like to say that rule. So the first few questions are just saying use properties to expand. So spread them out. So question number 1, notice what you've got. You've got log base 5 of X to the 7th. Well, to expand that, 7 is in the way. So moving down in front. So 7 times log. Now you don't have to put the times sign, but just 7 log base 5 of X. That's all you're doing. Same thing with number 2. Natural log 15 divided by 7 just means natural log 15 minus natural log 7. Okay, you're expanding it out. And then when you get to number 3, you are looking at 2 separate terms here. They're being multiplied. So that means log of 5 plus log of m. All right, so that's as far as you sort of need to go. Okay, when we work with the next ones, we got a little bit more involved. First thing I look at if I were to put a parenthesis around that information. So I really have 5 times x to the 7th times y. So I'm going to just split it up three ways. And since it's multiplication, I know I'm going to add these. So it's log base 3 of 5 added to log base 3 of x to the 7th added to log base 3 of y. And I'm almost done. The only thing I have to do is I have to fix x to the 7th. The 7 is in the way, so I need to move him down in front. So I'm looking at log base 3 of 5 plus 7 log base 3 of x plus log base 3 of y. Okay. When I look at number 5, a little unnerving, but wait a minute, I have a trinomial. And so when I see 8x squared plus 48x plus 72, I'm going to expand it. But first thing, I need to factor out what's called a GCF. That's the strategy. So when I do that, I end up with log, I'm going to write it above it, that way I got a little bit of room, log base 2, 8, and then what's left? Well, what's left is x squared plus 6x plus 9. Well, I hope that you remember that this guy right here is factorable. So I have an embedded multiplication sign right there, if I can get him to come up. My cursor will let me do it. It's right next to the 8, so I really have 8 times that. Well, multiplication implies with a logarithm to add. So I'm going to go log base 2 of 8 plus log base 2. And then when I factor this, isn't this x plus 3, x plus 3? Isn't that what x squared plus 6x plus 9 is? All right, well, when I get to here, I can't do anything with log base 2 of 8 yet. Plus, now, isn't this x plus 3 quantity squared? So this is rewritten as x plus 3 quantity squared. I want to take the 2 and move him down in front. Okay? And then the last thing I need to do is just think, well, log base 2 of 8. Wait a minute. I know what that is. I know what that is as a real number. 2 to what number gives me 8? Well, he's a 3. So 3 plus 2. Sorry. Forgot to turn my phone off. All right. Anyway, 3 plus 2 log of 2 of the quantity x plus 3. So that's as far as I need to go on that little guy. Okay? All right. Last one, same concept. I'm going to factor out a GCF. So when I factor out a GCF, I've got log of 4, base 4, but my GCF is a 4. So he's going to come out, and that'll leave me 3x plus 5y. Now, it's multiplication, so I'm going to split this up. Log base 4 of 4 plus log base 4, 3x plus 5y. And when I look at this front logarithm, log base 4 of 4, I'm going to rename that as 1. And then I can do nothing with the second term. So I'm just going to copy it down. I don't need to expand it out. It's already ready for me. Final answer. So 1 plus log base 4 of the quantity 3x plus 5y. All right. So getting to the number 7. When I get to this one, I've got a log of a log, and I have 10,000 to the 250x. So they want me to expand that out. So I'm going to work inside out, if you will. Okay, so here we go. I'm going to come over and say, well, first thing, I've got, let me fix that a little bit. I've got the log out front. Now, I'm focusing on this 250x. Well, he is, this. I'm looking at this term right here. 250x, he's in my way, so I'm going to bring him down in front. So 250x. And then I've got the word, or the log of 10,000. So step 1, I took the exponent of 250x and put it down in front of that very first logarithm in that parenthesis. Right there. Okay, now log of 10,000, that's a number. That's a 4. Remember, 10, base 10 is what this is really saying. 10 to what power gives me 10,000? 4. Just count your zeros. So the rest of that parenthesis says 250x times 4. Well, 250 times 4 is 1,000 x, and I've got the word log out in front of all that. Well, now I get to expand it. there's 1,000, and then there's an x. Those are two terms. So this really means log of 1,000 plus log of x. Well, what's log of 1,000? I can rewrite that. That's a number. Well, how many zeros? 3. So that is called 3 plus log of x. Final answer. Okay? All right. Now, those first 7 questions were expanding. These next ones are condensing. So I'm just going to try to see what operation connects these logarithms together. So when I get to number 1, on this next part, I'm going to look right here. Did a botchy job of circling it, but that's a minus sign. Well, minus means division. All right, minus means division. And when I also see this 4, that 4 used to be the exponent of that parenthesis. So this is what I really have. Natural log x plus 8 to the 4th power. Because down in front is what we did to expand it. Now I'm going to go backwards. So moving back. Minus means divide. And then same thing here. Now, do I have to write ln again? No, I just need one natural log term or, notation for it. But this is really here, down in front, x squared. I don't need to do anything else with it. That's it. Now, number 2, 3 is in front of every term. On number 1, 4 was in front of the first term, 2 was in front of the second term. 3 in number 2 is in front of every term. So it's like 3 came down in front of everybody. So he's there and he's there. So this is kind of what I got. Log base 6 x cubed plus log base 6 x minus 2 cubed. So remember, we're condensing, squishing it together. So write only 1 log base 6 and then put the terms together. So I'm adding here, so that means I'm really multiplying. So that's really x cubed and then x minus 2 quantity cubed. And you can stop there. You don't need to go any further. So when I get to number 3, down in front, 2 belongs there, 3 belongs there, 4 belongs there. And then I'm using a connector. Okay, well, the first 2 terms have minus. So I am dividing, that's x squared over y cubed. There's a plus sign. And then log z minus 1 to the 4th. Well, I have one more step because I can't have more than one logarithm statement, logarithm notation. So we'll combine these two. Well, addition means to really multiply those terms that follow the log notation. So it's x squared over y cubed and then z minus 1 to the 4th. Do nothing with it. Stop there. And then the one on the back, number 4, I'm kind of making notes of what I need to do. So that 4 moves up here, this 6 moves there, and that 5 moves there. So So just rewriting term by term, I have log, and inside the parenthesis I have x squared y cubed to the 4th power plus log. Now, 1 over x. That looks a little funny. But you know what? We, a few lessons ago, knew what we need to do with x to make it an exponent. So 1 over x means x to the -1. That's a -1 there. And then it's to the 6th power. And then minus log y to the 5th. So now, I'm going to try to make one logarithm for the whole thing. So I know that these two terms here that I want to underline need to multiply. And then this guy, since it's a minus sign, is going to be in the bottom. I'm going to divide by it. So this is basically what we've got. Log. And when I see this term simplified, x squared y cubed all to the 4th, that really means x to the 8th, y to the 12th. So this is x to the 8th, y to the 12th, and then coming over, I'm multiplying it times this term here, I'm underlining, x to the -6, and then dividing by y to the 5th. All right. Now, properties of exponents say same base, add them. So when I get to the end, I'm going to take 8 and -6 and add them. So that's going to leave me x squared. And then what do I do with the y's? Well, one's on the top, one's on the bottom. I'm going to subtract. 12 minus 5 is 7. So final answer, log, I can do it in parentheses if I need to, x to the 2nd, y to the 7th. So that's a condensed. All right, so far so good. So now we get to just evaluating some logarithms. Now, I'm thinking that everybody's calculator can do a logarithm with a different base. If it cannot, you need to let me know. So say Miss Stevens, ask me on Remind, how do I do a logarithm that I can't, have to do a different base than base 10? So, well, this is how you do it. If your calculator can't write a base like base 3 or base 5 or base, in this case, 2/3 like on number 2, what do? Well, this is called the change of base formula. All you do is, in your calculator, split the logarithm up. So this is really log of 16 divided by log of the base. So the base goes on the bottom. Think of it that way. The base belongs on the bottom. So if you did this in your calculator, log of 16 divided by log of 3, enter, you should get what that value should be. And it just wants you to evaluate it, and I've got down 3 decimal places. So in your calculator, you get something like this. So on number 2, log 0.308 divided by log of the base, just say 2/3. And in your calculator, typing that in, log of that would be 2.904. Now, again, this is a strategy for kids that do not have the ability to write a brand new base. So this is called the change of base formula. That's how you convert it. Okay, do you have to do it this way, you all that have that ability? No, just type it in like you see it. So I'm kind of helping those people that have a different type of a calculator. All right, so number 3, down here at the bottom, just says evaluate it. You're just going to type all of that in. That'll go into your calculator, no problem whatsoever. 0.99, no matter what calculator you have. Last questions. It says use the properties of the logarithms to write the following expression as a single term that does not contain a log. Okay, so I'm going to split this little guy up. He's in kind of 2 parts. It's base E. Remember what base E is. It's the opposite of a natural log. So I actually have 2 pieces. So first piece is base E to the 6th. That's a 6. Okay, I'm taking that exponent and busting it up. The second thing I'm going to do is remember down in front. That -5, let me write it out a little bit bigger. This -5 came from being the exponent of x. So this is really e to the 6th plus ln x to the -5 plus, and then copying down the rest, ln of y. Now, when I get to this next step, I'm going to combine these 2 guys right here. So that really means e to the 6th times, now, natural log here, when I combine this, this is L n. Now, x to the -5, he's a negative exponent. Do you remember negative exponents belong on the bottom? So that's really natural log y over x to the 5th. So remember, this is all part of an exponent. Maybe the way I wrote this is a little misleading. Let me fix it just a hair. E to the 6th. That's all part of an exponent. So here's the first part, e to the 6th. Well, natural logs are base e's also. So this is what my exponent is. Y over x to the 5th. Well, from our properties of logarithms that we did last lesson, e and ln, they just cancel, they drop. So what I really have is e to the 6th, and then that exponent just comes down, times y over x to the 5th. So you're just manipulating that exponent using the properties, and then this little guy right here, that'll cancel, and so it disappears. So the only thing you have to do is just simplify this piece here, and that is going to be the other part of your answer. Okay, so last 2 questions were just a little applications. Maybe in science class you've messed with hydronium ions and so forth, moles, things like that. So kind of backing up so I can see a little bit. It says a sample of a certain solution is determined to have a concentration of 2.62 times 10 to the -14th moles per liter. That's a hydronium ion. So what is its pH? So note that the pH of a solution is defined to be this little formula here. So I'm going to use this formula. So pH is equal to the negative log, and then this guy right here is that thing right there. I'm just going to substitute it in. So 2.62 times 10 to the negative 14th. All right, and then, guys, I'm just typing that in my calculator, just like I see it. Just like I see it. And so when I just type that in as is, 13.6 is my pH for that particular hydronium ion. That's all you do. It looks intimidating, but type it in. All right, last question. Moving our page up a little bit, giving myself a little bit of room. Intensity, sound intensity. They've given me this little formula here. That's the initial intensity, 10 to the negative 12 watts per meter squared. What's the intensity of a sound for which the decibel level of sound, that's how you measure sound in decibels, measures 127. So it says round to 3 places. And they give me this formula right here. So I'm going to kind of flip it around and do a little bit of work here, if that's okay. So I'm going to copy it down. So that's 10 log, and then there's 2 parts. There's an I, and then there's an I naught. Well, I naught is initial intensity. So we talked about that a second ago. Equals D. So I'm going to substitute in my numbers. Okay, I just flipped this formula around. I just switched it. So I'm going to plug in some stuff. So 10 log. I'm looking for I. That's what I'm doing. It says find your intensity. So I naught, initial intensity was 10 to the negative 12. Equals, and then decibels was 127. So step 1, I need to get some stuff by itself, because eventually I want to solve for that I. So I'm going to divide by 10. So if I divide both sides by 10, that disappears, and that becomes 12.7. So log of I over 10 to the negative 12 equals 12.7. And so I'm going to rewrite this as a logarithm, if that's okay. Or an exponent, excuse me. So this is just meaning 10 . Let's see. Just a second. Okay, sorry about that. I had to rewrite this out a little bit bigger. So this is what I get. This little piece right here is what I get when I divide by 10. Now, I added on a little base. So the red 10 means it's base 10. Log of something. If there's no subscript with it, it's understood base 10. So I'm going to rewrite this guy. Rewrite it as an exponent. So remember, from last lesson, we go counterclockwise. 10 to the 12.7 power gives me, that's a point, it's not showing up, equals I over 10 to the negative 12. Now, I'm going to put a 1 underneath that. I'm just solving for I. So cross multiply. So you're basically doing 10 to the 12.7 times 10 to the negative 12. And your calculator can handle that with exponents. So when you multiply that out, you're going to get the initial intensity. So let me change it. colors. There's the way you can see it. So initial intensity is going to be, when I multiply this in the calculator, 10 to the 12.7 times 10 to the negative 12, I get 5.019, and it's measured in watts per meter squared. So, making this problem a little easier, you take your intensity and you divide by 10. So I just scooted the decimal point, so it's 12.7. So 10 to that value times whatever they told me the initial intensity was, that's all I do is multiply those two numbers together. So do I really have to go through all of that? Probably not. As long as you can see where I got this section right here. So don't forget to divide by 10 to scoot your decimal point over, because it's base 10. So you're going to end up dividing by 10 is in front of that, okay? Because it's part of this formula right there. So divide by 10 first. So that intensity level scooted over. So 12.7. So 10 to the 12.7 times 10 to the negative 12 will give your answer to you, okay? So give it a try. Hopefully you're not going to have any major issues, but let me know. When is this due? April 19th. So when we come back from spring break, that's what you're working on. Alrighty, so please give a good faith effort. It's not really hard. You can get most of it, but if you have questions, please ask me. Okay, thanks. Have a great day.